All right, welcome back, everybody. We're going to be talking more about our polynomials, and we are going to be focusing on the term multiplicity. Okay, so we've been working with all of these zeros and finding our x-intercepts and all that stuff, but now we need to talk about multiplicity. So the multiplicity is the number of times a particular zero appears in a polynomial. So we've already done examples where, for example, x equals 2 shows up more than once. Okay, so today we're going to talk about what that actually does to our graph and how it affects things. So if you imagine, if I have this polynomial and this is how it factors out, okay, I get x equals 2, but notice this 2 right here. So that means that I have x minus 2 times x minus 2. So in fact, this 0 shows up twice. So we say that the multiplicity is 2. Okay, this one, x equals 1, only shows up once, so my multiplicity is 1. Okay, and then finally this one, x equals negative 1, shows up 3 times, so it has a multiplicity of 3. Now, the other things that I need you to think about, okay, putting this all together, what degree would this polynomial have? Okay, so remember that the degree is always equal to number of zeros. Okay, so a lot of people get this wrong because they think, okay, so there's 3 zeros, so it must be x cubed. Well, that's not exactly right, because this 2 right here shows up twice. So that already counts as 2 zeros. So really what you should be adding up are all of the multiplicities. So this 0 shows up twice, so that's 2 plus 1 plus 3. This would be a 6th degree polynomial. All right, so how does it affect our graph? So if r is a 0 with an even multiplicity, okay, so even multiplicities, then the graph touches the x-axis and then turns around at that 0. Okay, if r is a 0 and it has an odd multiplicity, then it crosses through the x-axis at r. Regardless of whether a 0 is even or odd, graphs tend to flatten out at zeros with multiplicity greater than 1. So that means, like if I go here and I have a graph here, if I have a multiplicity of 2, it flattens out kind of like right there through the point like that. Or if it has a multiplicity of 3, it still goes through, but it flattens out and goes up like that. Okay, so let's look at an example. Okay, so first of all, let's find the x-intercept. So here's the factored form that I found. So x equals negative 2. What's the multiplicity? Well, this 2 indicates that my multiplicity is 2. Okay, and then x equals 3 is my other one. It only shows up one time. So you'll notice at x equals negative 2 that my multiplicity is 2. So therefore, I know that at negative 2, notice how this graph goes to it, touches, and then turns back the other way. Okay? And then likewise, the multiplicity of 1 on 3 means that at 3, I'm going to go straight through the x-axis. Now, you may be wondering, how did they know that this bounced on the bottom of negative 2 and not up here? Okay, well, that all comes back to knowing your end behavior. So if you think about this 2 is positive, so that tells me that the right side goes up. And then again, I need the degree. Okay, so all this stuff is coming back up. The degree is 2 plus 1 is 3, which is odd. And that tells me that the left side is going opposite the right side. So the left side is going down. So you draw your end behavior first. So left up, or left down, right up. Okay, and I know that it has to go to negative 2 and bounce off of negative 2 because the multiplicity is even. So it hits, goes back down, and then at some point, it needs to go back up and go through 3. Okay, so I told you that the ultimate goal of this unit is, though, that we can draw comprehensive graphs. So the things that you're going to need in all of your graphs to have the most accurate picture of your graph are the x-intercepts, the extrema, or number of turns, and the end behavior. Okay, those three things are very important to your graph. Okay, as well as you need to include your x-intercepts, your y-intercepts, your extrema, okay, and enough of the graph to exhibit end behavior. So end behavior, extrema, y-intercept, x-intercept need to be on all of your accurate graphs from here on out. All right, so let's do one. So if you imagine, okay, so I have this thing, and now I'm not always going to give you it factored out. Okay, sometimes I'll have you factor it out. Obviously, that's why we did the rational root test and finding zeros by factoring and all that stuff. But in this case, it's already factored out for me. So I'm actually going to do all the zeros first, and then we'll go back and do the degree. So if you imagine x minus 3 squared. So 3 is a 0 with a multiplicity of 2. Okay, so x cubed. Okay, well, what would make that 0? Well, 0 would. And then it has a multiplicity of 3. All right, so for this next one, it may be a little bit not obvious right away, but if you set this equal to 0 and I subtract 5, 3x equals negative 5, divide by 3, I get negative 5 thirds, and it has a multiplicity of 1 because the exponent is 1. Okay, so notice that I've divided these into imaginary and real zeros. So these next two must be imaginary. So if you imagine setting this equal to 0, I get x squared equals negative 9. And when I take the square root, okay, square rooting a negative causes me to get imaginary numbers. So this is plus or minus 3i. Okay, so I have 3i, negative 3i. Now, both of those only show up once, okay, and that's how you get the x squared. Okay, so 1 plus 1 is that 2 right there. Okay, so we now have our zeros. Remember that our graph is only of the real plane. So I'm only going to be graphing the real zeros. So let's look. So I have 1 at 0. Okay, I have 1 at 3, and so what I typically do is I just make a mark and say that that's at 3, and then I make a mark out here and say that that's at negative 5 thirds. Okay, so the degree is the sum of all of your multiplicities. So 2 plus 3 is 5, plus 1 is 6, 7, 8 is our degree. Okay, so this should really say possible number of extrema, possible, not maximum. Okay, because the maximum would be 7, but I also want you to realize that it could be 5, 3, or 1. Perfect. Okay, so next thing, end behavior. Left side's doing something, right side's doing something. Notice that out front here, there's nothing there, so we assume that it's a positive 1. So that tells me that the right side should be going up. Okay, since the degree is even, the left side matches the right. Okay, so I already know that the right side's going to be going up, the left side's going to be going up. All right, so what I do is, first of all, from the left side, I'm coming and I'm approaching my 0 because I know I have to hit the x-axis at some point. And I look, okay, at negative 3, I have a multiplicity of 1. So at that point, I must go through that x-intercept. So I'd go through the x-axis. Okay, so in this case, my y-intercept, okay, because I'm getting close to my y-axis. So your y-intercept is whatever you get when you sub in 0 for all your x's. And in this case, this 0 makes everything else go to 0. So I know I'm going to go through the origin. And if you imagine, I'm going to be looking again at the multiplicity of 0. It's 3. That's odd, so I must go through that point as well. And now typically it probably flattens out a little bit and goes up. Okay, but for our purposes, we just need to know that it goes through. Now, it goes through, but it has to come back down towards 5, because I know it's an x-intercept. Or not 5, 3. Okay, can't read my own handwriting. And this one has a multiplicity of 2, so that's even. So it's going to bounce off that point and continue up like that. So if you notice, my number of turns is actually 1, 2, 3, okay, which is one of my options from here. Okay, and so that's how we're going to do accurate sketches. So what I need, again, x-intercepts, okay, extrema is correct, y-intercept, and end behavior. Okay, those things all need to be accurate. Okay, so I need you to try this one on your own. Okay, so go through it just like we did on the last one, and try it out. No, like seriously, pause the video, go back, do it on your own before you go forward. All right, so hopefully you paused the video and you figured out all the same stuff that I did on your own sheet of paper in your notes. Okay, right here, all I have left is that I need to graph it. So you should have got a degree 9 possible extrema, the evens less than it. Those is your real zeros, imaginary zeros, 9i and negative 9i. So let's look. So again, I'm just going to graph my real zeros. So let's see, we'll say positive 4 is out there, negative 4 is about the same distance out there, and we'll say 1/3 is somewhere in here. Okay, so let's see. If we go our end behavior right going up, left going down, okay, I'm going to approach negative 4, and I'm going to notice that the multiplicity is 1, so it's just going to go straight through that point. Okay, so now notice that I'm going to hit the y-axis before I hit my next x-intercept. So let's figure out where on the y-axis. So if I sub in 0, so I have 0 plus 81, okay, 0 times 3 minus 1, and 0 there. So I get 81 times, let's see, that would be negative 1 to the 5th, which is still negative 1, times 0 minus 16 is negative 16. So as you can see, this is a really, really big positive number, okay? So positive, positive, positive. So I'm actually going to erase this. And now again, how accurate do I want you to be? Well, I don't want you to like come in here and think that the y-intercept is really close to the origin, because in fact this one, it comes like way up here and then comes back down. Okay, so it goes way up here to something really, really big. All right, so at 1/3, I have a multiplicity of 5, which is odd, so it's going to go through, but it is going to flatten out a little bit right there at 1/3. And then finally at 4, it's also 1, so it's going to go through, and then it's going to go up forever like that. Okay, so that is a pretty accurate graph. Now this side definitely could use some work. It could look a lot better. So that looks probably better than what it originally was. All right, so the next step is that you need to be working on your accurate graphs practice. Okay, so accurate graphs practice. They are all problems sort of like this, where you're finding your zeros, graphing the multiplicity, and that sort of thing. Again, as always, if you have any questions, call me over. I'd be more than willing to help. Thanks.